Hello, my name is Evelyn Ellis, and I am part of the Costco Boomers, which includes me, Gavin Hewitt, Jacob Schatzley, Tag McVeigh, and Tessa Neal. For our CSCE 492 capstone project, we created the stroke cluster visualization. To get some context on this web app, I want you to meet Dr. Rutvik Desai. Dr. Desai is a psychology professor here at the University of South Carolina. As the head of Desai Lab, he coordinates a research team of several graduate students and has accumulated over 500 brain scans of patients suffering from a stroke. These scans translate to correlation matrices, which capture statistical relationships between brain areas based on the pattern of stroke damage. The damage in these areas are marked as lesions. The problem: how do we share his findings? This collection of over 500 MRIs is one of a kind. It's a massive amount of data, and it needs to be visualized intuitively. Many platforms exist already to visualize brain scans, but they require a background in computing to work the command line, to run heavy software, or even a supercomputer in some cases. Many psychology researchers lack this experience and lack this strength. So Dr. Desai needs an intuitive way to display this massive amount of data. For some context, here's a correlation matrix for the Johns Hopkins University Atlas. It is just a huge CSV file, and you can't really glean anything from all these numbers. For the .nii files, which are what most of the brain scans come as, here's one of the headers. This is just a really small amount of it. The solution is the stroke cluster visualization. The stroke cluster is a publicly accessible web application with capabilities to access and map all of Dr. Desai's research on a 3D rendered brain. Users can simply double-click on the brain or scroll through our regions database to explore correlations over two atlases. Pretty cool. Now meet Dr. Wu-Wei Feng. Dr. Feng is the head of the Stroke Recovery Lab at Duke University School of Medicine. He is interested in Dr. Desai's data. He explores it through selecting regions and exporting correlations to a .csv file, but he wants more. Dr. Feng wants his own collection of data visualized in the same intuitive way. Moreover, Dr. Feng wants to delegate this task to a new research assistant. He sends them several brain scans as .nii files and requests that the same visualizations be made. This research assistant has no background in computing. The solution is still the stroke cluster visualization. Dr. Feng's research assistant can now create an account, navigate to the profile section, and upload the files given to them by Dr. Feng with ease. In minutes, our web app calculates a custom correlation matrix based on this data and visualizes their findings on the same 3D brain rendering. Looking out, here are all of our goals. One, we want to run computations on large amounts of data securely. That means that we're not violating HIPAA, we're deleting those files, and we're making sure that everything's running safely. Two, we want to give labs around the world the ability to explore Dr. Desai's research. Three, we want to remove barriers across disciplines for a powerful visualization capability. Four, we want to allow researchers to expand their knowledge further by uploading the brain scans that they've gotten in their own labs. So let's take a look at how we achieved these goals.
Hi everyone, my name is Tessa Neal and I'll be going over all the technologies that we use for our web application. So to start with the back end, we use Python, specifically the Django framework. And Django was really amazing for our project because it was very easy to make APIs using the Django REST framework. And then to host our database, we use Supabase. And it had the perfect amount of resources available in the free tier, so it was really great for our project. And then we just connected our backend to the database using the connection string from Supabase. For the front end, we use JavaScript, specifically the Vue framework. We chose the Vue framework because it integrated very well with the NeView package, which we needed for brain rendering, brain interaction, and then also being able to extract information from brain imaging files. NeView itself did pose several challenges because it is a relatively new package that was created within the last few years. Also, a lot of the functionality is pretty specific. So, for example, we initially started out and we wanted to be able to have interaction with the brain through hover, single click, and double click. But due to the nature of KneeView, the developers only have added double click functionality. So, we had to alter our plan in terms of how we wanted to display all that information only using a double click. But luckily, Neeview was developed by faculty at the University of South Carolina, so we could meet with the developers and ask them questions to be able to get as much out of the package as we could. And then we connected our front end to the back end through API calls. And we also connected front end components to each other using Event Bus. As for deployment, we used Render to deploy both the front end and the back end. During this process, we did learn that the calculations in our web app are very computationally intensive. So with the current deployment tiers we were working with, we didn't have enough cores for processing and we exceeded our allotment of RAM during these calculations. So we needed to upgrade deployment by a few tiers. That was the only challenge we ran into there. Otherwise, render has been great. And then for testing, for unit testing specifically, we used the testing that comes with the Django REST framework. And then for behavioral testing, we used Vitest uh, because Vitest actually is the best behavioral testing for the Vue framework. However, Vitest does not incorporate very well with KneeView, so we had some challenges testing uh, all our components that dealt with KneeView. However, we were able to test the rest of our front-end components using Vitest.
Hi, my name is Tag McVeigh, and I'll be going through the regions of interest section of our project today. So first, when you go into the project, the brain's going to look like this. You're going to have your regions of interest on the right. Once you click the search bar, it's going to show you the last 5 searched regions. You can click out of that, or if you want to select one of those, you can select them, and it'll select it on the brain. The purple region is the one that's currently selected. Once you select one, it will show up in this little area here with a description. You can deselect. You can also select from the list, or if you want to search for one, you can also search that way and select that way. You can also alphabetically sort the lists. And if you want to, you can also click on the brain for a region. So if I want to post central drivers, I can click there. There's different regions that'll show up, but there's quite a few that you can click on. To get. So that's how you can click on the brain and see them. Once the correlations show up, you can also sort them numerically, and they'll sort that way. Finally, we also have 2 different atlases. So we have a JHU atlas and the HCPEX atlas. They both have the same function. They have different correlations because of different brain scans, but they work the same. If you want to download the correlations for the currently selected regions, you can download them, open them up, and then once you click and open it up, you can see the correlation matrix for that region that you selected and downloaded as well.
Hello, my name is Jacob. I'm a student in the CSCE 492 course in the Costco Boomers group, and I will be doing a demo with some of the different features that our web app has. So for starters, I've already selected the amygdala in the left hemisphere, just so that we can have these colors located up here on the brain to show some of the next parts. So first with the colors, we can change the color map that is being used. So this one is more friendly towards people who are red-green colorblind, and then this one here is more friendly towards people that are blue-yellow colorblind. For the purpose of the demo, I'll be going in the default version. We also have the option over here, so you can select which hemisphere you want to look at. So right now we're looking at the whole brain, and then we can also switch it over to look at just the left hemisphere if we would like, or just the right hemisphere as well. When you select either sides, you can also see that the regions and the available correlations do change based on what's actually available within that hemisphere. We can also go ahead and select any one of these to change the view that we want. So we'll just do a side view just because it has most of the correlations. And then lastly, I'll highlight the correlation bar down here at the bottom. So You can adjust this correlation bar and it will change which correlations actually show up. So it goes from -1 to +1. And right now it's set at, it'll show any correlation greater than this 0.0874 value, which is what causes these to show up. And then it gets rid of regions or makes regions reappear as you adjust the bar. So if I go all the way up, there will be nothing left except for that little purplish pink color where the actual region is at. And then you can reset it all the way back down to -1 and everything will be there. Thank you.
This is Gavin Hewitt. Okay, so I'm going to walk you guys through all of our profile functionality. So we'll start with creating a user. I'll say demo final and then say demo@final.com for my email. Now our passwords do have constraints now, so they have to be at least 8 characters long. They can't be a common password. They also have to have at least 1 letter and 1 number. So if I make a common password and try to create a user, you can see that it doesn't let me. So let me make it an actual password. And we're all good. So now we're back here. I can click profile up in the top left, and if I come over here to this pencil, I can edit my user information. It's USC, perfect. If I refresh, you'll see that everything is still the same. It has posted to the database successfully. If we come down here to choose files, I'll choose my test files.zip and hit upload. This zip file is in the assets of our release notes, so this file is available to you guys to replicate all of this yourselves. So please feel free, but otherwise I'm doing it for you. So uploading the files may take a second because the files are pretty large. Perfect, everything's done. So you can see down here we can download these files and it will successfully download them. And you can also delete them, but I won't do that just yet. And then if I come over here and hit make calculations, we're all good there. And it's going to make these calculations, and same with the file uploads. This may take a second. These calculations are pretty resource intensive, so it can take a second to run, essentially. All right, calculations are done. You can see we have our personal matrix right here. If I come back up to home, and I select amygdala L, it has no correlations, but it did before because our matrix is different. If I select amygdala R, you can see that we have our correlations right here. And if I use the slider, I can filter all of them. So perfect, everything's working exactly as it should. And then I can also come down here and I can download my personal matrix file. Now, my Google Chrome is being a little bit weird right now, and it's not going to show the name, but I promise you that is the correct correlation matrix. And then if I come back here to my profile and I delete out my correlation matrix, close that, come back here, and we look at our correlations again, we're back to our default correlation matrix. So it is completely responsive to what matrix the user has. You don't have to have one. It won't break if you don't have one. And then now if I click here and click log out, it deletes all of our files. We can't store these files because it's a HIPAA violation. And then if I do demo@final.com, 1, 2, 3, I log back in, go back to my profile. All my files are gone, which is perfect. That's exactly what we want to see, and that concludes our demo.